Hi guys, welcome back. So what we are going to do is learn about absolute value equations. If you just saw that little paw, that's my little cat PJ because he can't ever stay away from the screen. Sorry about that. Anyway, so the first thing we're going to do is a little brain dump. So the question is, what do we know about absolute value? And how do you think the stuff we know about it will help us solve or attack value equations? So in class we said that we know that it's always positive. Go away, PJ. That we have negative or positive inside an absolute value give the same answer. And so what we meant by that, we gave an example. If we do negative 4 and 4 inside our absolute value, both of them are going to be 4. Okay, and finally, we know that absolute value equations will have two answers. Let me give you a second to write that down, and we can briefly discuss it. Why will it have two answers? That's our essential question. Why does the solution for an absolute value equation typically result in a pair of equations? Well, that's because we have to account for both cases. You see where if I say equals 4, it could be a 4 or a negative 4. We have to account for both cases inside of our absolute value. So, we have to account for both cases. Positive and negative inside our absolute value bars. Alright, so the next thing we're going to do is going to be a very interesting thing. It's going to be very similar to what we did at the end of the last video. In our intro to absolute value, I gave you a couple of problems and asked you, what do you think the answer could be? So, here is an example of that. Well, if we have the absolute value of x equals 4, what could it be? Well, we know that it could be 4, or it could be negative 4. Because if we were to plug in a 4, we would get 4. If we were to plug in a negative 4, we would get 4, because the absolute value of both of those numbers gives us that. Okay. Take a look at the other one. We did the absolute value equals negative 4. Well, there is no number, no solution. Because there is no number that can go into an absolute value and come out negative. Okay. So these, when we asked about finding and solving absolute value equations like this, they're not that hard. What I want you to be able to do is solve equations that look a little bit different. They may look like that. So how might solving these be a little bit similar or different to the ones above? Well, there are things around the absolute value here. There are things being multiplied, added, subtracted to it. So we've got to deal with some things around the absolute value. Okay. Now also look, some of them have more than just x in our absolute value. So we're going to have to solve expressions inside our absolute value. But something that I'm glad someone said, all of them should still have two answers. So, still have two answers. All right. So there are a couple of steps that we have when it comes to absolute value equations. The first step is to isolate the absolute value. That means the absolute value is alone on one side of the equation. So, abs val alone on one side of equation. Then we're going to pull the expression or equation, but pull whatever's inside the absolute value out, set it equal to the positive and the negative solution. So, pull out expression and set equal to positive and negative solution. After doing this, you can check it. So you can always check your answer. You don't have to check every single time, but checking your answer is a good idea when we're starting a new thing you've never seen before. And here's a big, big tip. Never change the inside of the absolute value. Never, ever, ever change the inside of the absolute value. Well, this may look like, oh my god, that's a lot of steps, but you've been doing this already. You've just done it kind of in your head. So let's take a look at that example we did earlier and show you exactly what I mean. So remember when I asked you if the absolute value of x is equal to 4, what is x? Well, the first thing you did was isolate your absolute value. Well, you didn't have to do anything. The absolute value was sort of already by itself. So you did step 1 without having to do step 1. Step 2, you pulled out your answer, x and x. You knew there were going to be two different answers. And step 3, you set your solution equal to the positive and the negative of the solution. So you already did it without knowing. And then all that's left for us to do is check it. Well, the absolute value of 4 is in fact 4, and the absolute value of negative 4 is in fact 4. So boom, we just did it. All that's going to change now is that the equations are going to get a little bit more difficult. We may have things to do to get that absolute value alone. Alrighty. So take a look at number 1. We have what's the absolute value of x in 7 equals absolute value of x plus 2. So first things first, I'm going to rewrite it. Our first step always with absolute value equations is get the absolute value alone. Well, to get our absolute value alone, the 2 is what's bothering. So how do we get rid of it? Well, we're going to treat that absolute value as if it was an x that we were trying to get alone. Meaning that we're going to get rid of it using SADMAP. If it's adding, we're going to subtract. Okay, so we're going to bring down the absolute value of x because we haven't used it. 7 minus 2 is 5. Okay, our next step tells us pull out your expression, x and x. All right, we're doing it. Then our next step says set your solution equal to a positive and a negative. So equals 5 equals negative 5. And that's it for solving this one. So you may write it as x equals 5 and x equals negative 5. That's fine, but you also may see this written in your exams as 5 and negative 5 with the little squiggly brackets. Either way is fine. I don't care which way you write it, but I just wanted you to be aware of the two ways it can show up. So, for fun, let's take a check here. So, we want to know, does it equal 7? Well, the absolute value of 5 plus 2. Well, that would be 5 plus 2, and that would in fact be 7. Then we want to do the absolute value of negative 5 plus 2, which would just give us 5 plus 2, which does in fact give us 7. Yay! And last but certainly not least, sometimes, now when graphing with absolute value, it's mainly going to come about when we're talking about the inequalities that we do it with. But you may be asked to graph the answer, and I'm only going to do one on here for an equation. If you are, it's very simple. Our answer was 5 and negative 5. So put 2 dots at 5 and negative 5, and you have answered your equation. So if you're ever asked to graph an equation, an absolute value equation, just put the dots where your answers are on the number line. Alrighty. So that was our first one. Let's try one a little more difficult. Now look at what we got here. Not just an X in those absolute values. So the first step, well, I'm going to rewrite it because rewriting it will make it easier for me. So now the first step is to get your absolute value alone. Well, that's already done, so I'm just going to go ahead and put a check mark by that because it gave it to us alone. Sometimes that's what's going to happen, guys. You're going to get it alone. Now, in order to solve, we have to pull it out. So, 2x minus 3, 2x minus 3. Okay, cool. We wrote it out. Now we need to set it equal to a positive and negative version of the solution. So this should be equals 1 equals negative 1. Alright. So now we just solve these like normal equations. So we add 3 to each side here. And we get 2x equals 4. Divide 2 on each side. You get x equals 2. We got our first one. Yeah. We're going to do the same steps to this equation over here, but it's going to be different because our solution is negative. So add 3 to both sides. Bring your 2x down, but instead of a 4, you're going to get a 2. Because negative 1 plus 3 is 2. Divide by 2 on each side. And you'll get x is equal to 1. So our answer is x equals 2 and 1. Not too bad at all, right? Let's do a check. So, if we're going to check this, we're just going to plug it in. 2 times 2 minus 3. So we're going to get 4 minus 3. And then we're going to get 1. And the absolute value of 1 is in fact 1, so it works. Let's try it out over here. 2 times 1 minus 3. 2 times 1 is 2 minus 3. 2 minus 3 is negative 1. And the absolute value of negative 1 is in fact 1. Yay, guys, we did it. Alright. Now let's try another one. It says, what is the value of x in 3 times the absolute value of x plus 6 plus 8 equals 5? Well, first things first, we have got to get that absolute value alone. So I'm going to go ahead and rewrite it. So first step, get Absalom. Well, what's bothering your absolute value? Well, a 3 and an 8. How do I know which one to start with first? Well, remember, SADMEP is not going away. We're going to do SADMEP. So, subtraction and addition first, meaning that our 3 will have to be handled later on because we've got an 8 to get rid of. So we'll go ahead and subtract 8 on both sides, bring down what we haven't used, equals -3. Okay, now it's time to get rid of that 3. Whenever you see a 3 next to an absolute value, it's just saying that it's multiplying. So what we're going to do is the opposite, right? And divide. So we're going to get the absolute value of x plus 6 is equal to -1. Alrighty, so here's where you might think, well, pull it out and start setting it equal. But is there anything that's going to come out of here that will ever give me a -1? Absolutely not. So we have ourselves here a no solution. If you were, because I had a really cool question in class, if you were to pull it out and solve it and try to figure it out and end up with 2 different answers, if you were to check your answer and plug it in, it wouldn't work. It wouldn't give you a 5. So if you happen to forget and you feel kind of weird about it, maybe like, oh, this doesn't look great, then go ahead, plug it in, and if it doesn't work, you'll see you have a no solution. Now, I'm going to give you some caution when it comes to our no solutions here. Always isolate your absolute value before deciding no solution. Because if you don't isolate your absolute value all the way, you may think, oh, there's a negative number, that's a no solution. And after isolating it all the way, it doesn't stay negative on the other side. Let me show you what I mean by that, by giving you this same problem with one thing changed. So if this was -3 times the absolute value of x plus 6 equals -3. Well, then what we do is we divide by -3. Then this would become the absolute value of x plus 6 equals 1. This has solutions. But if you would have said, oh, it's negative and went on and said no solution before isolating your absolute value, then you would have been wrong. So please, 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 isolate your absolute value before you decide no solution. Okay? If when you isolate that absolute value all by itself, there's a negative number, then you're good. No solution in. Alrighty. I'm going to keep going. We're not going to jump over the one there, but we are going to do our example. Apply an absolute value equation. So, Kennedy's boat is cruising at 25 miles an hour. She plans to cruise at this speed for the distances shown in our diagram. A wants us to write an equation that models the number of hours x that she will travel. So this, in class we talked about this, how this could be a little weird looking. If you're driving down that road and you've seen those green markers that tell you what miles we are, this is kind of what we're thinking about with the boat. You can see that green marker before you pass it, or you can have seen it after you've passed it. So what's happening here is she's going to travel some distance. So that's going to be 25x minus the 80 mile marker, because we don't know if she's past that mile marker or if she started before that mile marker. That's where our give or take 10 miles comes in. She may have been 10 miles away from the mile marker, or she could have been 10 miles past the mile marker. Okay? So, the 25x here is the distance she travels. This entire thing within our absolute value is her final distance from the 80 mile marker. Let me move that up. I'm so sorry. And this one here, our 10, is 10 miles from the 80 mile marker. So a key thing that I want you to notice here before we turn the page and solve it is that an absolute value equation is used when we have a plus or minus situation. So if it's like plus or minus, give or take, or things of that nature, this is when we know that we're going to use an absolute value, because your absolute value is going to break it into cases where you have both the plus version and the minus version. Alrighty, let's go solve this. So what you're going to notice on this side is that I and the printer do not get along. So this was your try it from the other one, so kick that part out. So what are the minimum number and maximum number of hours Kennedy's going to travel is our question. Well, we know our formula. 25x minus 80 equals 10. So we just have to figure out if she's plus 10 miles away or minus 10 miles away from our 80 mile marker. So if she is plus 10 miles, then we solve it for the positive. If she is minus 10 miles, we solve it for the negative. Now all we have to do is solve this like a normal absolute value equation, not inequality, my bad. We're going to add 80 on both sides. Bring down our 25x. It's going to be set equal to 90. We're going to divide by 25. And if we type 90 divided by 25 on our calculator, we get 3.6. Okay. Welcome, PJ. So now we're going to add 80 on the other side. But this time, we're going to get 25x is equal to 70 because our 10 was negative. We're going to divide by 25 on both sides and get x is equal to 2.8. So we were asking for our max and min. So Kennedy will travel for at least 2.8 hours and at most 3.6 hours. Let me let y'all look at that real quick. Alrighty. I'm going to say that absolute value equations are not always easy, so I'm going to work my best to make sure that I don't give you too many of them myself, honestly. But we will have at least one that we have to deal with. Okay, so that this video doesn't get too long, I'm going to skip doing this page here, which is our math, lit, and vocab, which is usually where we talk about how to justify each step. If you need the answers for this page, you can pause and take a pic. Pause and write it down. Basically, all we did for here was write down and decide and argue and justify why we could do what we did. Or you can always see the math notebook in class. What I want to do for our remaining little bit of time is try out a couple more problems with you. So let's look at number 1. We have the 3 times the absolute value of 3x. 3 times the absolute value of x plus 5 equals 8. So we know we need to isolate our absolute value first. So we're going to divide by 3. Then we get the absolute value of x plus 5 equals 8 over 3. Just because it's a fraction doesn't mean the rules to solve it has changed. So we're going to pull it out. We're going to go over here and do x plus 5 equals 8 over 3. X plus 5 equals negative 8 over 3. And then we're going to solve them like we usually do. We're going to subtract 5 on both sides for both of them. So if you subtract that and you put it in your calculator, you're going to get a negative 7 over 3. If you are using your fancy calculator, it'll give you a negative 7 over 3. If you are at home doing homework and you write it down as a decimal because your calculator doesn't do that, that's fine with me. X equals negative 23 over 3. Or you could see it written in our favorite, the little curly brackets. So the point of this problem was to show you that you may not always have easy, pretty numbers like 5 and 2 and 7 and 8. You may have crazy, outlandish ones. Alrighty. For sake of time, I'm not going to do number 2. Number 2 is basically similar to the first one we did. However, I do want to take a browsing look at number 3. So notice for number 3 that we're going to have to add 3 to each side to get our absolute value alone. Well, when we do that, we get x plus 6 equals 0. Just because we have a 0 here does not mean no solution, move on. It means that we're going to pull our number out like we usually do, but we're just going to set it equal to 0. Because can 0 be positive or negative? No, it's only going to be 0. So in this case, we go ahead and we subtract our 6. And we get x is equal to negative 6. This will be the only time we have one solution. So only time we have one solution is when we have 0 as the thing on the other side. Okay? I would also like to work out number 4 and number 6 with you. So let's look at number 4. For number 4, we're going to subtract 5 on each side. That's going to leave us with a negative 7. 5x equals a negative 13. Then we're going to divide by negative 7. That's going to leave us with a 5x equals 13 over 7. It turns positive because we have 2 negatives there. We follow the same steps. Pull your 5x out twice. 5x. 5x. Make it equal to a positive and a negative 13 over 7. We are going to solve this the exact same way. You have to divide by 5 on both sides. Just because this is a fraction does not mean we do not divide by 5. If you are using our giant calculators here at school, you can just type this in as, in parentheses, 13 divides 7, then put divide 5 on the outside, and it'll give you your answer. If you're using your ones at home, do 13 divides 7 first, then type in divide 5 to whatever that answer is. It should give you 13 over 35, or if you're at home, it will give you some fraction version of, or some decimal version of that, and if you write the decimal version of that, that is fine. I am never going to penalize you for not having the giant calculator. Alright, and again, you may see it written as 13 over 35, negative 13 over 35. One thing I'd like to point out that I've seen in this video, and I'm sorry it's going over a little over 30 minutes, but you'll be alright, is that sometimes you're going to get the negative and the positive of the number as an answer, but other times they're not going to be that way. So never just assume after you found one answer you know the other, just change the sign. That is not how absolute value works. Alrighty. With this one, I do want to caution you, I'm not going to work it out, but that this one will be a no solution. Okay? Now, I want to work out number 6 because we haven't tried one like it before. So, we're going to add 5 on both sides. We're going to get 2 times the absolute value of x plus 4 all over 3 equals 14. Then, we're going to get rid of denominators by multiplying, because we hate our denominators. So you're going to get 2 times x plus 4 is equal to 42. Finally, to get abs all by itself, you need to divide. So you're going to get x plus 4 is equal to 21. So sometimes there are going to be multiple steps you have to do to get your absolute value by itself, and if there's a fraction, we do not fret, we just follow the steps until it's alone. Now we pull this out. X plus 4 is equal to 21. X plus 4 is equal to negative 21. And we solve by subtracting 4 on each side. We get x is equal to 17. And x is equal to negative 25. Yay! We done it! So this was just a brief version. I didn't do any of the extra practice in here. If you're looking at these and you're looking at those extra practices and you're struggling, please don't hesitate to come see me and ask me questions about how it works. What I'm here for, and I want to help you. Alright guys, I hope this video helps you do a quick review over absolute value equations. Have a good day.